If you were asked to name the most terrifying disease in human history, you would probably say cancer, or maybe rabies, or some ancient plague that wiped out entire cities. But hidden inside human DNA is a rare failure that feels almost more disturbing. It does not melt your skin. It does not fill your lungs with blood. It attacks something so normal that you never even think about it. It destroys your ability to sleep. At first, you're just tired. Then the nights become strange. Your body begs for rest, but your brain refuses to fall into it. Days begin to blur. Thoughts become slow and sticky. Reality starts to feel like a dream that never ends. You do not instantly go insane. That would almost be easier. Instead, you become trapped in a half-awake twilight state. Your mind stays on, but it no longer knows how to shut itself down. The disease is called Fatal Familial Insomnia. It is not ordinary insomnia. It is a rare inherited prion disease that damages the deep brain systems involved in sleep. And once it begins, the ending is almost always the same. The person slowly loses sleep, then coordination, then memory, then control of the body. And eventually, the body collapses. Not because sleep is pleasant, but because sleep is necessary. Fatal familial insomnia proves one terrifying fact. Sleep is not just rest. Sleep is a biological wall keeping you alive. But you do not need a rare genetic disease to see the dark side of sleep. Every single night, you close your eyes and surrender control of reality. Your muscles become weaker, your senses fade, your consciousness disappears. Your body lies there warm and defenseless, while the mind switches into a hidden mode. From an evolutionary perspective, this should make no sense. For hours, you become blind, silent, and vulnerable. You cannot watch for predators. You cannot search for food. You cannot protect yourself. And yet every animal with a complex nervous system is forced to do some version of it. Birds do it, mammals do it, reptiles do it. Even creatures that live in dangerous places still have to disconnect. Sleep is so important that evolution accepted the risk of unconsciousness. That means whatever happens inside sleep must be worth the danger. The standard story sounds simple. You work all day, your brain gets tired. Then sleep recharges you like a phone plugged into a wall. But that explanation is too small. Your brain does not simply power down. Your brain never truly rests. The moment you lose consciousness, the real work begins. Sleep is not the absence of activity. Sleep is an active biological takeover. When you are awake, your brain is busy surviving the outside world. It watches faces. It predicts danger. It controls movement. It filters noise. It calculates social signals. It keeps the body alive, second by second. But when you fall asleep, attention turns inward. The brain stops managing the world and starts managing you. To understand why this happens, you have to look at the hidden pressure building inside your head right now. As you listen to this, every thought burns energy. Every blink burns energy. Every small movement burns energy. Your cells use a molecule called ATP, the tiny currency of life. But when ATP is used, it leaves behind a chemical signal called adenosine. As the day goes on, adenosine builds up in the brain. It does not knock you out instantly. It slowly adds weight. It presses down on your wakefulness. It makes the world feel duller. It makes your thoughts slower. It makes your eyes heavier. This is one reason exhaustion feels like a pressure, not just a mood. You can cheat this system for a while. When you drink coffee, caffeine slips into the brain. It fits into adenosine receptors and blocks the sleepiness signal. For a few hours, the weight feels lighter. You feel sharper, faster, more alive. But the adenosine has not disappeared. It is still waiting in the background. Caffeine does not pay the debt. It only hides the bill. And when the caffeine wears off, the debt comes back with interest. That crash is not weakness. It is chemistry collecting what you borrowed. But adenosine is only one part of the trap. Inside your brain, there is a constant battle between wake and sleep. On one side are systems that push you upward. They release chemicals that keep attention sharp, muscles ready, and thoughts moving. On the other side are systems that pull you downward. They use inhibitory signals like GABA to quiet the nervous system. Sleep does not arrive like someone gently turning off a lamp. It arrives more like one army slowly defeating another. Most nights the transition is smooth, but sometimes the handover glitches. You are lying in bed. You are almost asleep. Then suddenly, your entire body jerks awake. For one split second, it feels like you are falling through the air. This is called a hypnic jerk. It may happen when the brain misreads the relaxation of the body as danger. Say, your muscles go quiet. Your sense of position fades. The part of the nervous system that still wants to protect you panics. It fires an emergency signal through the body, and you snap awake, as if catching yourself from a fall that never happened. One theory says this reflex may be ancient, a leftover alarm from a time when sleeping in a dangerous place could kill you. Your body is not stupid, it is just old. But the chemical battle is only half the story. Deep inside your brain, above the point where your optic nerves cross, sits a tiny master clock. It is called the suprachiasmatic nucleus. It contains only a small cluster of neurons, but it controls the rhythm of almost everything. Hunger, temperature, hormones, alertness. Sleep. This clock watches light, not with imagination, not with belief. It's biology. When daylight hits your eyes, signals travel into this clock and tell the body that the world is awake. When light fades, the clock changes the message. It speaks to the pineal gland, a tiny organ buried deep inside the skull. Ancient cultures sometimes called this region mysterious. Some animals even have light-sensitive structures on top of the head that look like a primitive third eye. In humans, the system is hidden deeper. When darkness arrives, the pineal gland releases melatonin. Melatonin does not knock you unconscious like a drug. It is more like a signal flare. It tells the body that night has begun. It tells the organs to prepare for a different mode of existence. For most of human history, this rhythm was tied to the planet. Sunlight pulled us awake. Darkness pulled us down. But modern life broke the signal. We stare into bright screens at midnight. We flood our rooms with artificial daylight. We wake up to alarms in winter darkness. We eat when the body expects sleep. We work when the body expects repair. And every cell is forced to pretend that time does not matter. But time does matter. Many cells in your body contain their own microscopic clocks. Even outside the brain, cells can keep a rhythm. Your body is not one clock. It is a city of clocks, and modern life desynchronizes the city. Scientists often call this social jet lag. You can damage your timing without ever stepping onto a plane. Every week, your biology can be dragged across invisible time zones. Your alarm says morning, your brain says night, your stomach says confusion, your hormones say something is wrong. This is why sleep loss does not feel like simple tiredness. It feels like the whole body has been forced to lie. But there is an even stranger question. If modern sleep is so distorted, how were humans originally supposed to sleep? The answer is not as simple as 8 perfect hours. In pre-industrial Europe, many people appear to have practiced segmented sleep. They went to bed soon after darkness. They slept for a first sleep. Then they woke for a quiet period in the middle of the night. Some prayed, some talked, some read, some visited neighbors, some simply lay awake in the dark without panic. Then came a second sleep until morning. To them, waking in the middle of the night was not necessarily a disorder. It was part of the pattern. Artificial light changed that pattern. Industrial schedules compressed the night. Coffee helped people push through the day. Work demanded a more efficient body. Slowly, sleep was redesigned around productivity. We did not simply discover the modern sleep schedule, we built it. And then we started calling everything else abnormal. But no matter how we arrange the night, the sleeping brain still follows its ancient machinery. The moment you fall asleep, you begin descending through sleep stages. First, the outside world fades. Sound becomes softer. Thought fragments break apart. Images flash and vanish. Then the body moves into deeper sleep. This is where the repair becomes physical. Your heartbeat slows. Your breathing changes. Your temperature drops. Your muscles relax. And inside the brain, something almost violent begins. The spaces around brain cells appear to open wider. Fluid moves through the tissue. Waste products are carried away. The brain begins cleaning itself from the inside. This system is often called the glymphatic system. It is one reason sleep feels less like rest and more like maintenance. Imagine a city that cannot stop running during the day. Cars fill the streets, machines overheat, trash piles up, signals jam the wires, then night arrives. The people vanish, the roads open, the cleaning crews flood in. That is closer to what sleep does to the brain. It is not a vacation. It is a dangerous cleaning operation performed while consciousness is offline. At the same time, the rest of the body enters repair mode. Growth hormone rises during deep sleep. Tissue repair accelerates. Bone and muscle maintenance increases. Immune signals shift. Wounds can heal more efficiently when sleep is protected. This is why sleep deprivation does not just make you feel bad. It makes the body worse at rebuilding itself. Then, after roughly 90 minutes, the cycle begins to reverse. The brain rises out of deep sleep, but it does not fully wake. Instead, it enters one of the strangest states in biology. REM sleep, rapid eye movement. During REM, the eyes twitch beneath the eyelids. The brain becomes intensely active. In some ways, it can look almost awake, but the body is locked down. Your major muscles are chemically suppressed. You are not meant to act out your dreams, so the brain paralyzes the body to protect it from the mind. This is the domain of dreams. For thousands of years, people treated dreams like messages from gods, spirits, or the future. But modern neuroscience suggests something even stranger. Dreams may be part of the brain processing itself. Every day, you absorb more information than you can keep. Faces you barely noticed. Sounds that did not matter. Worries you never finished. Half-formed fears. Fragments of conversations. Your brain cannot preserve everything. If every connection stayed forever, the system would drown in its own noise. So during sleep, the brain strengthens some connections and weakens others. Important memories become more stable. Useless patterns are reduced. Emotional experiences are replayed, tested, and sometimes softened. In a way, dreams may be what it feels like when the brain edits itself. random faces, broken places, impossible rooms, people from your past standing inside places they never visited. Not because the dream is meaningless, but because your mind is deciding what deserves to survive. You are not literally watching memories die like files on a screen, but you may be seeing the sparks of a system deciding what to keep and what to let go. Some researchers suggest nightmares may have another purpose. They may act like threat simulations, a safe hell built inside the skull. Your brain can trap you in a chase, a fall, a fight, or a disaster. Your heart races, your fear system activates, your body prepares for danger, but the danger is not real, it is rehearsal. A brutal training program written in the language of fear. Sleep is not passive in other animals either. In some sleeping chameleons, researchers have observed skin brightness shifting along with sleep-related brain rhythms. That does not prove the chameleon is painting its dream onto its skin, but it is still unsettling. Even when the animal is disconnected from the world, its body is not still. The sleeping brain is still conducting the body like an orchestra. Humans have pushed this boundary even further. Some people learn to become aware inside the dream without waking the body. This is lucid dreaming. It sounds like a myth, but it has been tested in laboratories. Lucid dreamers have answered researchers from inside REM sleep using planned eye movements. The body remains paralyzed. The room remains quiet, but somewhere behind closed eyes, a conscious person is responding. That means the border between waking and dreaming is not a wall. It is a door, and sometimes that door does not close properly. Imagine waking up in bed, your eyes open, you can see the room, you know where you are, but you cannot move. Try to lift your hand, nothing happens. You try to turn your head, nothing happens. You try to scream, but the body does not listen. A pressure builds on your chest. The room feels wrong. The shape appears in the corner. Gork, tall, watching. This is sleep paralysis. Your mind has woken up, but the REM paralysis has not fully released. The dream system is still bleeding into the waking world. Historically, people blamed demons, witches, spirits, and night monsters. But the horror is mechanical. The brain has simply failed to switch states cleanly. You are awake enough to be terrified, but asleep enough to hallucinate. Sleep paralysis is frightening because it reveals the truth. The feeling of being yourself depends on switches you do not control. But there is an opposite failure that may be even more dangerous. What happens when the body wakes up, but consciousness does not? This is sleepwalking, somnambulism. In this state, movement systems can activate while memory, judgment, and full awareness remain offline. The person can walk, open doors, move objects, speak, sometimes even perform complicated actions, but the self is not fully there. One of the most famous cases happened in Canada in the late 1980s. A man named Kenneth Parks fell asleep on his couch. Later that night, he got up, took his car keys, and drove across town. He entered the home of his wife's parents. He attacked them. His mother-in-law died. Then he drove to a police station and reported what had happened. The case became terrifying because the defense argued that Parks had acted in a state of sleepwalking automatism. Automatism means the body performs actions without voluntary conscious control. Court accepted that sleepwalking could remove the voluntary element of the act. He was acquitted. The disturbing part is not that sleep makes people evil. It does not. The disturbing part is that when the sleep system breaks, the boundary of personhood becomes fragile. The law had to confront a nightmare question. If your body acts while your conscious self is offline, who committed the act? Some people face another malfunction entirely. Narcolepsy can force sleep to invade waking life. A person can be talking, working, or sitting at a table. Then the boundary collapses. In narcolepsy with cataplexy, strong emotions can trigger sudden muscle weakness. Laughter can drop someone to the floor. Surprise can make the body fold. Joy can trigger collapse. It is as if part of REM sleep has broken into the day. The mind may still be awake, but the body receives the wrong command. Freeze, funnel, shut down. And there is another way sleep can invade your life. Microsleeps. When the brain is sleep deprived enough, it stops asking for permission. Tiny fragments of sleep break through wakefulness. Your eyes may remain open. Your body may still be sitting upright. But for a few seconds, parts of the brain go offline. A driver can travel down a road and lose several seconds of awareness. A student can stare at a page and miss an entire paragraph. A worker can blink and return to a world that has already moved on. This is the terrifying truth about sleep debt. If you refuse sleep for long enough, the brain starts taking pieces of it by force. You can delay the shutdown. You cannot cancel it, because sleep is not just something you do. Sleep is something the brain does to you. This is why dreams feel so powerful. People often believe they predicted the future. Someone dreams of a crash, then later gets into one. Someone dreams of losing a tooth, then receives bad news. Someone dreams of a place, then sees something similar days later. It feels supernatural, but the explanation is usually more human. The brain is a prediction engine. It constantly calculates risk from small details. Google habits, fears, pain, stress, patterns you barely notice while awake. In dreams, those patterns can become images. If you have been driving recklessly, your brain may simulate a crash. If you have been ignoring stress, your brain may turn it into pursuit. If your body feels discomfort, the dream may translate it into a symbol. A tight throat can become choking. A stomachache can become a wound. A fever can become fire. Not prophecy. Not magic. The body whispering while consciousness is offline. This may be why some dreams feel like warnings. They are not messages from the future. They are messages from systems already running in the dark. You spend roughly a third of your life in this hidden state. You treat it like an inconvenience. Something to compress. Something to defeat with caffeine. Something to sacrifice for work, screens, money, deadlines, and entertainment. But beneath the surface, sleep is a high-stakes biological operation. Every night, your brain changes your chemistry. It suppresses your muscles. It cleans its own tissue. It repairs the body. It edits memory. It rehearses fear. It holds back hallucinations. It keeps the self stitched together. And when any part of that system fails, reality becomes unstable, too little sleep, and the brain starts shutting down while you are awake. Broken REM paralysis and nightmares enter the bedroom. Broken awareness, and the body can move without the person fully present. Broken sleep regulation, and waking life becomes infected by dreams. Broken deep sleep, and the body loses one of its most basic repair systems. This is the hidden horror of sleep. It is not just that you become unconscious. It is that the person you call yourself depends on unconscious systems working perfectly. You do not manually choose to paralyze your body. You do not manually choose which memories survive. You do not manually wash waste from the brain. You do not manually control the clocks inside your cells. You simply lie down, close your eyes, and trust the machine. Tonight, when the lights go out and your thoughts begin to drift, remember what is really happening. You are not just resting. You are being taken offline for maintenance. Your brain is entering the parts of you that you never control. It will silence your muscles. It will rewrite parts of your memory. It will clean the organ that creates your reality. It will run simulations you may wake up calling dreams. And for a few hours, the system will operate without you. Most mornings, it gives you back to yourself. You open your eyes. You remember your name. You recognize your room. You stand up as the same person who went to bed. But that normal miracle only happens because the hidden machinery worked. So when sleep comes for you tonight, do not think of it as weakness. Think of it as a controlled disappearance. A nightly surrender, a biological gamble that keeps you human, and all you can do is close your eyes, hand over control, and hope the system brings you back.